My name is Sean Fitzpatrick. I'm playing the role of moderator today, so hopefully you won't hear much from me. I come from Ketchum PR down in DC, and I'm really excited to join you guys here today. But before, again, you really don't want to hear from me, I promise. So I'm going to hand it over to our panel to introduce themselves and answer the first question tonight, which is how, in your guys' experience, how important is the nutrition for preterm baby in research and clinics, and what do you guys see that come to life? Dr. Fuchs?
Males first?
Yes, always. Closest first.
Thank you. Yeah, I'm Chris Fuchs. I'm a trained neonatologist, pediatrician. I did my training in Tübingen in Germany, then moved to Switzerland, to Zurich and Bern. Was there for about 8 years, then moved to Germany, back to Greifswald, which is the northeastern part of Germany, close to Sweden. Lund is our partner university, by the way. Was at Sharon Grawargo for 10 years, and then moved to McMaster in Canada. Nice time as a Jack Sinclair research chair. Worked a little bit in this very big unit and was focusing a lot on growth and nutrition of preemie babies. I'm also interested in gentle ventilation and improving outcomes. And then 3 years ago, moved back to Germany, to Nuremberg, took over chair-in-chief position of a newly founded medical university, which is fun to work with because it's a blend of state system and private financed university, so more North American type. So big challenge to do that. And but I'm 50% of my work, in fact, is really doing research and continuing what we have done in Greifswald and in McMaster. Question is, how important is growth and nutrition for preterm babies? It's very important. I think it's easy to explain because 5/6 of the body mass of a baby that is being admitted to an NICU at 25, 26 weeks until discharge is generated in the NICU. So we have a big responsibility. And we can do everything with these babies. We can make them short, we can make them long, we can make them thin, we can make them fat. Depending on what we put into the system, these babies have to digest what we put in. Unfortunately, I think the know-how about nutrition and what it does to growth is not as advanced in clinical practice as many people focus on respiratory and other kinds of intensive care, which not all babies need, but all babies need to grow, and it's very important, and I leave some other stuff for you.
Yeah. Oh. So my name is Dr. Laura Medor. I am a neonatologist at Bay State Medical Center located in Springfield, Massachusetts. So my story isn't as complicated as yours. I haven't been around the world. I'm basically born and bred in Massachusetts and stayed there, did my training at Tufts. I'm 4 years into being an attending. And I've always been interested in growth and nutrition. Starting off in fellowship, I was very interested in my clinical project as a fellow, looking at growth in donor breast milk fed babies. And so I realized, in the US, donor breast milk is certainly on the rise, as we've seen in a lot of the studies that were presented at PAS today. And the growth compromise that happens from that is of a huge concern. And as well as I looked at the developmental outcome effects of that donor breast milk feeding. And in my study, at least, it was a small observational study, but it did show effects on neurodevelopmental outcomes in the donor breast milk fed babies. And we all know that donor breast milk doesn't have the macronutrient concentration nor the micronutrient concentration that mom's milk has. So it just kind of sent me on this path of being interested in nutrition and what's in milk, really. And we know it's variable. We know that mom's milk is variable, but we certainly know that donor breast milk is probably even more variable because of the processing of it. So that's how I came to kind of want to know a little bit more about growth and nutrition and macronutrient analysis. And as far as why I think nutrition is important for preterm babies, I think it's the foundation of everything. So we all know that mom's milk and good growth is better outcomes in multiple factors, all the three-letter acronyms of NEC and BPD and ROP. So I feel like it's the foundation, and if you don't have a good, well-growing baby with appropriate gains in body mass and growth overall, then your outcomes overall are going to be poor. So that's all I have to say.
Great. Well, it's great to be here, especially to see some friendly faces. I'm Sharon Grawargo. I am a professor of nutrition and pediatrics at Case Western Reserve University School of Medicine, Cleveland, Ohio. I've also been a clinical registered dietitian in a NICU for 40 years, and people will say, oh, do you want me to introduce you and say you've been doing that for 40 years? And I'm like, yes. I love it. It's been a wonderful career, and I feel privileged, really, to have seen the arc of nutrition through neonatology, worked with just wonderful people, and over the course of my career, nutrition has become more of an emphasis, I would say, for sure. And pivotal of that, in that, is the importance of human milk. And we all know that human milk is one of the few evidence-based therapies that we can offer our babies to prevent poor outcomes. But the challenge, and this is what we want to talk about, I think, tonight, is that it varies, the composition varies, and we need to fortify it to meet their nutritional needs, and yet we don't know where we're starting. And I'll say one more thing and then turn it back to Sean, but what I've noticed, and I'm sure you have too, is we all know who the mothers are that are producing the cream, and then we know the mothers who are producing the skim milk, because all you got to do is ask the nurse, and they'll tell you that mother over there is given a skim milk. So you can see the difference in fat concentration, but what you cannot see is the difference in protein concentration. And in the little bit of milk analysis work that we've done, you can look at a variety of mothers, and you'll have mother number 1 with a very low protein concentration and mother number 20 or whatever with a very high, and you can't see that difference without some milk analysis. So it's very exciting to have this opportunity. So, Sean?
Thank you, guys. Well, Sharon, I think you hit on something that's really interesting, which is, wanting to measure and needing a starting place. And I know each of you have worked with the MIRS human milk analyzer so far in different settings. So Sharon, maybe we could start with you, of why you decided to start working with Target Fortification and the human milk analyzer.
So the question is, why would you be interested in this? And it's because, you'll be providing a standardized approach. And the numbers, I always tell people, they'll show me their numbers, and the numbers are wonderful. Oh, we're giving this and we're giving that, but the baby's not growing. And they'll say, well, why? We're giving such a great plan. Well, probably you're not giving that because you're assuming a certain concentration from the mom's milk or the donor milk or whatever you're using as the base, and you know what you're adding, but you don't know where you're starting. So I think most of us have gotten into this because we're just befuddled by outcomes that don't match what the numbers on our paper are saying. So, other comments?
Yeah. Laura, I know you guys conducted a study recently. Could you maybe share a little bit about that using the MIRS?
Yeah, so we got the MIRS about a year ago. It was obviously not FDA approved at that time, so it was under research investigation only. So we were trying to think of small little projects that we could put together to kind of answer some clinical questions, but also get our staff used to using the analyzer. Not that it's that complicated, but it does take some practice. So we wanted to look at the donor breast milk macronutrient concentration at our local milk bank, which is the New England Milk Bank. So that's never been looked at before. I know there's other donor breast milk banks that even label their milk, but we are not so lucky in New England to have that opportunity. So we never know what we're going to get. So we thought it would be interesting. So we got approval from the milk bank itself and through our IRB, and we just looked at 30 different batches of donor breast milk and looked at the macronutrient concentration of each batch. We looked at the triplicate within each batch just to see, are we getting consistent results when we look at triplicate within a batch, and those were always consistent and spot on, so that was good to see. But then when you look at different batches of the donor breast milk in New England, huge variability. And this is kind of a study that then is going to launch into hopefully more studies of protocols of how in the United States, when we do use a lot of donor breast milk, how are we going to implement that into just our everyday usage of the milk? For those of us that get the donor breast milk from a Himbana center, that's not labeled. But huge variability, especially in the fat, we saw a lot of variability. In the protein, we just saw low protein overall across all 30 samples. And when you compare it to the breast milk standards, it's a statistically significant difference. And then we also looked at, hypothetically, if you were to fortify using a bovine-based fortifier. At our unit, we use a Similac high-protein HMF. When you fortify that milk, it certainly does not meet the ESPGHAN standards that are published of what preterm babies should be meeting. And overall, the whole calorie content was way lower than what we're anticipating. So we know that all of our donor breast milk fed babies, the reason they're growing so slowly is they're not getting what we intend them to get. So.
Well, that's great. So, Chris, you've had the opportunity. Are now turning into this era. I've been able to move from research to clinical. So, can you tell us a little bit of your experience with the Mirus HMA in a clinical setting as well as research?
Yeah, maybe I start with a similar journey because my interest in nutrition and growth started basically in Switzerland when we saw that by introducing more gentle care and other stuff, being sepsis rates on babies survived better. And then we got into these growth issues. So the more babies survive, the more growth becomes important. And then in Greifswald we did a study where we changed our nutritional protocol and realized we improve it, but we are still on the lower part. We are losing too many babies that are not growing well. And then looked into this breast milk issue and were aware of this, became aware of this variability and started then in McMaster to measure it. What the striking thing for me was, I mean, everybody knew that breast milk has variable contents of this and that. But I was always thinking, oh, could we have breast milk that is rich or breast milk that is poor in all nutrients? So basically kind of diluted or non-diluted breast milk or concentrate. And that is not true. Problem is, and we published that in Acta Pediatrica a few years ago, in about 1,000 breast milk samples, that when you look at the different macronutrients and plot them against each other, they are all over the place. So kids receive any kind of diet: low protein, high fat; low protein, low lactose; high protein, low fat, everything. And there are only certain combinations that work with growth and other combinations that are suboptimal with growth. And just enriching, giving more of them in volume or giving more of a fortifier doesn't work. So this individual variation of all three macronutrients, that was an eye-opener for me, and where we said we have to measure. And then, to come to your practical question is, what did we do with the Mirus? We first validated it, because the very old versions were, as you said, you're on the market since 13 years. There were still some trade-offs and some things to improve. And first, we were also not on the same page, right? But then came on the right page, because we did this with wet lab and then realized, okay, these devices have so much improved that we can use them really in clinical practice. And we conducted two studies, one pilot study. It was published in Journal of Pediatrics a few years ago, and then finally got funding from CIHR for a double-blind randomized control trial in 105 or 103 babies below basically 1,000 grams and around 27, 28 weeks of gestational age, and found considerable differences in those babies that were on target fortification compared on those who were not. And those were about 10-15% better weight, not to the expense of fat mass. So they really accreted lean mass. And if you look into physiology, what triggers growth to have the right amount of protein and the right amount of energy, I think we managed to get that into the babies using the Mirus. It was a lot of work. We can talk about that later, what it means. But that is our practical experience, and it really turns out into better growth. And those babies who benefit the most are those who receive breast milk with natural low content, which is simple. Once you see the results, it's logical, but you need first to show it. So the babies that have breast milk with relatively rich protein or other don't benefit from the intervention so much, but the others do. And we also showed that we might have an effect on neurodevelopmental outcome. We just missed statistical significance, but that is because of low numbers.
So I just, I think all of us are thinking in the US anyway about the opportunity now to have milk analysis in our units. And so people who have done it on a research basis, it's one thing, but to think about it clinically, before tonight I was trying to kind of put my thoughts together of what we need to plan if we want an analyzer in the clinical area, like what would that entail? And I came up with this. I'm anxious to hear what you all have to say. So I did a who, what, where, when, and why kind of thing. So I was like, well, which babies would we analyze their milk for, and who is going to run the equipment? I think it's really important. It's an expensive piece of equipment. It takes some doing. So which babies and who's going to run it? So, and then where will it be done? Do you have it in a milk lab or your formula room, or where is the piece of equipment going to be housed? When, like weekly, every 2 weeks, more than once a week? I think that depends a little bit on the baby and how old the baby is, but when are you going to do it? What is it going to be, just mom's own milk or your donor milk? Which milk are you going to analyze? And then why? And I think most of the time we're talking about a targeted fortification, but there's also the opportunity to do a little bit of lacto-engineering where you would put, high energy milk together to make a feeding for a particular baby, or a baby who has chylothorax and you want a skim milk kind of thing, and you could test that. So there are other applications. So I just think as we move into the clinical area with this equipment, it's such a great opportunity, but we want to make sure that it's done in a thoughtful and sort of, I don't know, I'd be interested in what these guys see, or I don't know if you guys have other comments.
Yeah. No, I've been thinking a lot about that, because now that we have the FDA-approved version, we can actually now implement it in everyday use. So now I've been inherited the charge of trying to kind of develop a protocol for our unit. And so, like Sharon was saying, you really need to know your resources, who's going to do it, who's going to implement it, and then even how. Okay, you target fortify. That sounds so easy. But it's not. Who's actually going to do the calculation? How do you do the calculation? What standards are you looking to attain? Because of course there's always ranges, but as the breast milk, and if you have breast milk technicians to actually kind of do this fortification, and they like hard, fast numbers. So how do you come up with, you get the value? That's almost the easy part, is finding where the analyzer is going to be and who's going to analyze, but then just really how to implement it in your NICU. So we definitely need some protocols out there that people are willing to kind of experiment with, and I'm sure maybe based upon, some of those that have used it in clinical practice, we can kind of start to borrow your protocols of how you actually really implement it within a NICU. It sounds easy, and it could be, but I think certainly sharing information would be great for us newbies. I'll call us the newbies.
That's great. Chris, you want to share some of that information with us newbies here in the U.S.?
Yeah, welcome to the rest of the world. In the study, in the double-blind randomized control trial, we really developed a study protocol. We developed an algorithm and a prescription sheet where it is really very easy to calculate once we have the numbers. And I agree, you need to see how frequent do you need to do it. We published a paper where we did all the model calculations from doing it daily to during weekdays, due to Monday, Wednesdays, Fridays, due to Monday and Thursdays, or once per week, and came up with at least, all based on these 1,000 samples, came up to the agreement that maybe 2 times per week is a minimum that you should do it. If you can afford to do it more frequently, then you get closer to the target point. Otherwise, you get just more variation. If you do it less, then you can come off the targeted value a little bit. So basically 2 times per week is doable. The question, who and how. So how is easy. Obviously, you need to be trained. Who, ideally, 1 or 2 trained people in the unit who always do it, because it can be like with any kind of device. You have pre-analytical and analytical errors, so you need to be trained. It's like with blood gas analysis. You don't carry that around or put it into a hot and warm place and then do the measurements. You want to have a standard approach, and that is the same with milk analysis, I think.
Are you done?
No.
No.
I've never done.
Uh-oh.
Nobody of us has never done.
Yeah. No, I just wanted to say about the difficulty of getting a representative sample. It's tough, right? You want to?
No, go.
Yeah, go. We need to get a representative sample. There was somebody in the audience, we were talking before we sat down here, and she's used the equipment quite a lot. In fact, she's collecting milk at this meeting to take back to her milk bank, which is awesome. But anyway, I was asking her what has been her biggest challenge, and she said, if you don't get a good representative sample, you're not really achieving anything better than guessing, but you want it to reflect that mother's milk, and it needs to be, mixed well and taken from enough of a collection that you represent that well. So, yeah, that's, you want that.
And that's a 12 to 24 or 24-hour sample for mom's milk. Like a 24-hour pumping collection of 24 hours
24 hours.
Yeah.
Yes.
is the
We take
standard.
the batch of the day. Basically. Yeah.
Okay. That's great. So I think, Chris, I'd be interested to know a little bit more in the same kind of conversation is how much time, does this take, once, how much more time is needed for an HMA process as you guys dive into this and add it in as a new diagnostic tool kind of in your tool chest?
So once you get the sample, the representative sample of the batch of the day, so not truffe du jour, but the batch of the day, then you have to sonicate. It means you have to really make sure that the homogenization, that fat and all parts of the milk are nicely mixed together. That's it's a relatively short time. That is many seconds to a minute, and then depending on how much you have there, and then you put it into the device, and then you get the readings like you get it in a blood gas machine. So it takes approximately the same amount of time. You need to clean the device, but that can be done by someone else, whatever. but at least you have the numbers at that moment, and then you can start calculating, and if you want, even put it in. No, I mean with someone else. I mean, obviously you have to do it after each measurement, but if you want to have it urgently, it's like in a blood gas machine, you get it immediately, then there's not a lot, you can start thinking about how much do you put in and can start that process. Then something that is very important, what we found out and suggested, and that is, I think now also common practice, that we need to follow good laboratory and clinical practice, GLCP or GCLP, which means we need to run standards and quality controls to make sure that the devices run the same way every day. That was not happening in the early years, but is now being done, and that is very important. Like, again, with a blood gas machine, you have your quality control samples, and when you are in, then it's fine, and if not, or if they are going in a certain direction, then you need to look in your device, into your device whether it's still doing the right thing. And I think that is very important. That takes a little time. But overall, it is, I find it very comparable really to a blood gas measurement, and then the extra fortification, depending on how your unit is being run by dietary assistants or whether nurses mix at the bedside, it becomes more or less complicated, but usually very straightforward, I think.
Are you done? I think one of the things that's going to help us is that the latest standards for building a NICU include the requirement to have a milk lab in close proximity to the NICU. It's very clear in the latest standard. And the third edition of the Academy of Nutrition and Dietetics Infant Feedings book, which is sort of a little manual for running a milk lab. It's very clear. You should not be mixing at the bedside. You should have a place really where human milk, the supply is managed. Both the mother's supply and any donor milk, it needs to be managed. You know, back in the day, like 20, 30 years ago, we didn't have that much mother's milk sitting around. But now, I think all of us, we have a lot of milk around. It needs to be protected and managed. And you need personnel and a space. And that is good because this fits right into that. And that's the direction we're moving, which is a good thing.
So that, for newbies in this space like me to a certain degree, what are, taking us back to the patients and what this important work you guys are doing, what are the clinical outcomes later in life to poor nutrition and malnutrition during the first weeks of life?
Well, certainly a paper from Stevens et al. I'm reminded of that even in the first few weeks of life, poor protein content is linked to lower IQ scores, I think by like 7 to 10 points, if I can recall. So certainly we know that nutrition is paramount for these babies. And so the more that we can adequately fortify, the better that we can grow, the better developmental outcomes these babies will have, not only in the short term, but also in the long term. But certainly we do need these studies with milk analyzers and targeted fortification. We need these long-term outcomes. So anybody out there that's interested in getting a Mirus, we need to combine our efforts and look to make sure that the outcomes that we intend to happen are actually happening in the long run.
The other thing I worry about is because when people come to me and say the baby's not growing, the knee-jerk response almost all the time, although it's changing a bit now, is to add more energy. They're going to add more calories. And if you don't know what's in the mother's milk, so you just add more. And if it's a high or a low protein to calorie ratio, you're giving more energy, but not enough protein. And what that ends up doing is, and you alluded to this, Chris, that it's, what I call cube babies. They're short and they're fat. And, we're not just in the business of growing babies. We want that growth to be of an appropriate body composition, and we know that it's lean body mass that's really associated with these better neurodevelopmental outcomes. So we need not just growth, but growth of an appropriate body composition, I think, for the best outcomes, and milk analysis will help us sort of titrate that.
It'd be great to have cost analysis data too. I mean, that's also very interesting that, at PAS today I saw a cost analysis of donor breast milk. Yes, donor breast milk is expensive to purchase outright, but when you look at the cost savings that donor breast milk will prevent necrotizing enterocolitis and decrease length of stay and decrease parenteral nutrition, it actually is cost saving to implement a donor breast milk. Well, will breast milk analyzers also have that same impact? Yes, it's a upfront cost, but in the long run, I do think it will benefit our babies. Is there a certain kind of cost benefit to kind of fronting that cost so that you can have better outcomes for your baby? And certainly that's another study that we need to show.
Getting one step back about how a unit is run, I agree that usually it should be done by dedicated people that only are mixing or preparing the milk. But unfortunately, that is not what is being done. Even in big units, you can have shortage, and then that's why I said it can be done by the nurse at the bedside. I'm not a fan of that, but then it becomes also less safe, I think. It's really better. Also, the whole target fortification is better if it's prepared. And MAC, we had a dedicated lab room, milk lab room, that was prepared for that purpose, where only the 4 dietary assistants did it. But if you have a shortage of dietary assistants, then it goes back to the nurses at the bedside, and that can happen from one day to the other, unfortunately. In terms of measurement and growth, cost savings, it is maybe important to understand that all this target fortification is not providing super fortification. We don't give extra nutrients. We identify those babies that receive breast milk that is not rich enough in nutrients when we give standard fortification, we stay below the Espegan recommendations. And the Espegan recommendations are relatively, let's say, sound basis in terms of energy, protein, and carbs, what should be given and fed. So target fortification identifies babies at risk for non-optimum growth. And I think that is the importance. It's not providing super fortification. We are not giving extra calories. We are just giving that what babies should get, but would not get because Mother Nature plays a different game with preterm babies compared to term babies. For term babies, it doesn't matter. Term babies suck as long as they are satisfied, and that is the same thing if you eat a fondue bourguignon, so a meat fondue, or you eat a cheese fondue. You eat different amounts because you sense that cheese fondue and meat fondue have a different protein and fat content. And before you have reached critical levels in serum, you already have sensed that what is in nutrition. Your belly, and you are trained to do that. Term babies have that as well. Preterm babies don't have that. And that's why it's so important that we feed babies the right thing, because they are not auto-regulated. Why could this play a role in terms of cost savings is the following. If assuming that we are feeding babies nutrients that are not good to achieve the right growth in terms of weight or whatever, babies accumulate fat mass beyond 32 weeks. So beyond that postnatal, beyond this gestation age, babies should start to become a little bit more round and not anorectic, only having muscles and bones and skin. That is not enough. They need fat because it is a postnatal adaptational process. And that has to do with thermoregulation as well. If babies don't accumulate enough fat, they will not be able to thermoregulate and to keep the temperature. And keeping temperature is one of your discharge criteria. So you can discharge babies in 1900 or 2000 or maybe even at 1800 grams if they can maintain the temperature. But that means babies that have the normal amount of fat around their body can do that much more easier than others. And I think providing that kind of nutrition will help also accumulate the right amount of fat mass. So that could be cost savings at the end, but nobody has calculated it so far.
That's great. I find myself with the chocolate fondue more, which is probably part of the problem. But
that comes after the cheese fondue.
There you go. All right. Well, I'm going to ask one more question for you all, and then we'll hand it over to the audience here. But what we have FDA approval. It's an exciting time. What are you guys most excited about as we've turned this chapter and we have this new tool in the tool chest to kind of what comes next inside the NICU in a clinical sense? And Laura, maybe you can start.
Yeah, I guess I'm most excited to see what the growth outcomes are going to be in general, and then how is everybody at different institutions going to implement it? You know, just kind of being in that mode right now is, you know, how is Bay State going to implement it? How are all the other institutions, based upon where they keep it, who's going to do it, how is implementation going to happen, and then how is it going to affect the babies in the long run? And just as a side note too, my also big concern is how are parents going to take this? And I don't know if that's been looked at, but anecdotally, there's been a few moms that have actually shared the results with. So, you know, because we were testing some of the moms in our units, even though we weren't really supposed to. But just to kind of, not to target Fortify, but just to kind of see what they were producing. And I shared the results with the moms, and they were ecstatic to see, wow, I'm making that good quality milk. I mean, I suppose if they're not making good quality milk, it's not a good thing to show them per se. But the moms that were really working hard, who were having trouble with supply, but really were sticking with it, it was almost like a little badge of, you know, an award or badge of honor, like I am making this high quality milk for my preterm baby. It's one of the, you know, few things, I mean, moms and dads can do many things for the preterm babies, but, you know, one of the big things is providing milk. And so it really helped to kind of bolster their courage to kind of keep going and keep pumping. So I was very excited to see that with our mom.
Yes, I think that I think overall it will be an encouraging thing for moms that we're placing that much value, that we want to see what's in it. I guess what I'm wondering will happen, I mean, we've all seen lots of studies, done little studies in our unit or whatever. I'm sort of anxious to see how when we start doing it more routinely, sort of what we're going to find out about our population. The other thing I'm wondering about is we suspect sometimes that mothers bring milk in that's not theirs. You know, it could be their sisters or their neighbors, and I'm just wondering what we're gonna see. You know, we haven't done it on almost every mother over time, all of the time. It'll be interesting. I'm also interested in triplets, twins and triplets, particularly triplets. We've had several triplet sets where there's sort of the impact also of just different kinds of mothers, I guess. So, Chris?
Yeah, so that's right, that moms can be very excited, but can also be the other way around. You show the results and there's only 0.6 gram protein in there, then they feel guilty that they are so bad milk producers. I've seen that, and unfortunately you can't really do a lot because maternal dietary intake, we talked about that previously, does not really influence composition of breast milk. Maternal body composition does, but no mom wants to gain body fat to produce more fat milk. So what I think is very important, on one hand, if that is being implemented, I think we need two things. Excellent education. I think can not only sell the devices and then let people do. They need to understand nutritional physiology and what the needs for babies are. That's one thing. The other thing is we need to have kind of protocols as well about how it's being measured, as you said, the who, what, why, and so on. I think that is very important. Otherwise, we might see too diverse data and then coming from the wrong institutions if the data are being pulled together, and then this method would be discredited. That would be terrible. So we need to implement it absolutely the proper way. I think that is very, very important.
Absolutely. Okay, I'll open up to the crowd here. Does anyone have a question? I can come bring you the mic, whatever. Oh.
Well, thank you very much. It's good to hear all your comments. So we've been using under a research study using the MIRAs for target fortifying babies with chylothorax. So one of the things that we implemented just to make sure to err on the side of caution is never to down fortify. So I guess what I mean by that is we would never say a mother had 1.5 grams per deciliter. We wouldn't reduce the protein that we would give down to 1.2 or whatever your baseline is. I guess I wanted to get your thoughts on that. Does that seem like a good thing to do?
Yeah, just speaking from designing my own protocol, I would always have a set minimum.
Yeah, and then just not down fortify.
And not down fortify.
And then
exactly.
when would you feel uncomfortable? At what point would you feel uncomfortable if you knew if you didn't down fortify? At what point would you feel uncomfortable about the protein concentration in the milk, or would you?
I wouldn't, because that's what we'd standardly do anyways.
I get it, yeah.
So I guess I just would try not to think about it. I don't know if you guys have any thoughts.
In our randomized trial, we measured all batches that were fed to babies. And we realized, so with true wet lab against MIRAs, so we really knew what babies got. And we always, I think you can get up easily up to 1.6, 1.7, because the standard fortifier actually available in most countries doesn't have a rich enough protein content. There are no new fortifiers coming out from companies that have 0.5, 0.6 grams of more protein. And that was what we basically have added nearly to all babies. So you can easily afford 0.1618 gram per deciliter. And that you have a sample that is higher is very, very rare. And I would also never down dilute that. And it also depends on the amount of energy. So the protein to energy ratio needs to be balanced. as well, right? But I would never down dilute. Baseline? For what? 1.2 for mother's own milk, and for donor milk it's 0.8. Yeah, we realized in that study that we added routinely 0.4 gram per deciliter. That was in many samples not even enough.
You could always follow BUN too, as a marker. Like if you thought that you were giving excess protein, then probably in those babies, and generally we do follow BUNs in our unit every couple of weeks. So that would be one thing that maybe I would follow specifically in those babies that are giving excess protein too.
May I say something?
Sure.
The problem with BUN is that it can come up when you have a relative excess of protein to energy. So the problem can be too much protein or not enough energy. You cannot decide what is going on there without measuring. So BUN is not 100% clear what it does. We have seen high BUNs with good protein intake, normal protein intake, but because the fat content was unbelievably low. Maybe one thing about implementation. I implemented it in Nuremberg 4 or 5 months ago, and our staff, especially the attending, got excited, and also the nurses, when they saw the values. They started to think and said, oh, this is only 0.8. No, that baby cannot grow, because we provided the physiology behind it. So they really were into it when they saw the data. It's like, again, coming back to blood gas analysis. Let's assume you do ventilation without blood gas analysis. The baby's not doing so well, and now you're assuming, should we go up with this? Now there is a unit where you are able to measure blood gases, and now you see, oh, the CO2 is 85. You will think, oh, might have a ventilatory problem, and I might look into certain things more than just guessing around. So you start to think, and the buy-in was amazing from nurses and doctors, just by seeing the values and also be able to influence them.
To go back to that point about mother's diet, I think this is such a common question I get when we'll tell mothers that we're going to fortify, and they'll be, why are you fortifying? Well, the milk doesn't provide, and the first question always is, can I eat something different? So I think that conversation is going to come up a lot more. Secondly, when I first started following this, I guess I was more focused on the protein problem. I think other people were. But the longer I get into it, the more I'm paying attention to energy, because I don't know if it's just poor letdown or all the plastic or what it is, but it is a nutrient problem.
Hi, thank you so much for the talk. My name is Sarah Tabassum. I'm one of the pediatric trainee from Dublin, Ireland. There was no question, but it's just to second what you all have said. I'm doing a research that includes measuring the macronutrients of maternal breast milk of infants less than 32 weeks and looking at their growth and body composition. So very much my interest area. As Dr. Mador said rightly, that I sometimes give them, my research participant, give them the results, and it just keep them reassured, and just to keep doing the right thing, keep expressing, because there's been time that been up and down with the preterm babies that they would actually get more reassurance. There's no set number of values that I would give them, obviously, but giving them the results for those who are actually trying to quit, but looking at the baby that has been very sick, I think that's one of the positive feedback that I got. Thanks so much.
You can put a positive spin on anything, really. Even if it's not the greatest milk, you can still put a positive spin on it just to kind of give them encouragement to continue. So, something I've learned.
I think we have time for one more.
I have actually two questions. One is, what size of NICU would this sort of equipment be useful for? And the second question is, we keep talking about targeted macronutrients, targeted fortification. Exactly what are we talking about? I mean, what's available here in the US that we could use? Thank you.
Yeah, and so that's why I'm so interested in how different units are going to implement it, because what's been used for the fortification process in Europe is different than what we have available in the United States. So we use, And so a lot of units use Prolacta, we don't, but you know that there's going to be some units out there that have a Mirus analyzer and they use Prolacta to fortify, so they're going to have a slightly different protocol. We use bovine-based Similac. We also use microlipids. We also use the Similac liquid protein as well. So you can get pretty high protein contents using a combination of those as well as the fat content from the microlipids. But every unit that you kind of talk to has different repertoire of fortifiers and supplements to use. So you either have to decide to work within your unit and use what you have, or start thinking about ordering other entities that maybe other units that have published on, have those similar things. But really that's up to each individual unit. And as far as size, really could benefit any size NICU, whether it be a small level 2 up to a large level 4. I could see really any baby that benefits from growth, any preterm baby that benefits from good growth, could benefit it. So even if it's a small unit, it would still have benefits.
I think there's some opportunity, we've talked about this in Northeast Ohio, to do cooperative, having an analyzer in one hospital and doing analysis for other units. So I think, because you do want sort of economies of scale kind of thing. On the point of what you're going to fortify with, I want to just make sure we're all clear that we want to start with a multi-nutrient fortifier. What we do not want people doing is just fortifying protein, carb, fat, and looking at energy. You must start with that multi-nutrient fortifier for the mineral component. So I think what most of us are talking about is we add the multi-nutrient fortifier, you get your calcium, phosphorus, things very important. And then there are some modular proteins. We want to use a sterile liquid probably, which does a bit of displacement, so you got to deal with that. And then there are some modular fats. There's the microlipid product, there's the prolactic cream product, so there's some energy sources. So it is, some measuring of various things, not just adding the packet of fortifiers, so that's why you want to be sure it's accurate and safe. So there will be protocol development. It's going to keep lots of dietitians in jobs. I'm really excited.
Like the osmolarity component.
Oh, very important. The osmolality component is something you want to think about. So, Did you have a second question? Very good.
I was thinking whether I should still say something.
So you should say nutrition is the best part of neonatology.
Nutrition is the best part of neonatology.
There you go. Excellent. Well, we want to thank you all, Dr. Fuchs, Dr. Grawargo, Dr. Medor. Thank you so much for joining us today. We have some gifts for you, and in lieu of a larger speaker's gift, we've also made some donations to the March of Dimes and a Better Start in your guys' name. So thank you guys so much for joining us tonight. Thank you all for coming. It's been a joy to have this conversation and learn more from my perspective, so thank you so much.